All right, for our next section in chapter 9, we're going to talk about similar right triangles. So taking a right triangle, dropping in altitude, and creating multiple smaller right triangles that we can relate through similarity. Now, we talked about similarity back in chapter 7, and so some of those concepts are going to be coming back into play here as we go through these right triangles, and so we're going to have to kind of go back over some review stuff as we kind of introduce this new topic. Now, before we get into that, there's also a thing in this section that we talk about called the geometric mean. This is a way that we could solve problems with our similar right triangles, but we're going to focus more on the process we used back in chapter 7 just for consistency's sake. So for the geometric mean, between two numbers. So they're going to give us two numbers and say, what's the geometric mean? And so to do that, we are going to use our proportions. And so when we set up a proportion, that's one fraction equal to another fraction, basically what's going to happen is our geometric mean, so what we're solving for is x, just like normal, and then the two numbers we're working with are going to be the a and the b. And so every time we set up for a geometric mean, we start off with two fractions, so we just start with this. We're going to put what we're solving for, x, on one diagonal, so they got to be diagonal from each other, and then we put the two numbers, like 3 and 7, diagonal from each other. So that's going to be kind of the setup. So as we're looking at an example here for geometric mean, if we look at this first example right here where we're looking at 4 and 9, notice right away they set up the fraction. So I've got the x's along the diagonal and then the numbers along the diagonal. And so that's going to be the setup every time. Now, when I have a proportion, we use those diagonals to multiply and solve. So I cross multiply here, x times x is x squared, 4 times 9 is 36. And so then all I need to do is find x by square rooting both sides. So that's what you see in this next step here. We take the square root of both sides, and since 36 is a perfect square, we finish with x is equal to 6. Now, in the other two examples, when we're looking at the means here, so 3 and 15, we start with our proportion. So the x's are along one diagonal, the numbers are along the other. When I cross multiply, I get x squared is equal to 45. When I take the square root of 45, this is not a perfect square, and so now we have to split it up using our perfect squares. And so 45 can be broken down as 9 times 5. Since my 9 is a perfect square, it gets to come on the outside. And so the square root of 9 is 3. The 5 is not a perfect square, so it stays inside. And we finish with 3 square roots of 5. As we look at the last example, same type of deal. We start with our proportion. So the x's go on one diagonal. The numbers go on the other. We cross multiply and get x squared equals 20. When I take the square root of both sides here, 20 is not a perfect square. And we're not going to work with decimals yet, so we try to simplify it down. So 4 times 5 gives me my perfect square of 4. That can come on the outside as a 2, and then the 5 has to stay put on the inside, and so we get 2 square roots of 5. So as far as the geometric mean is concerned, we're looking for, can you set up the right proportions? So put the x's on one diagonal, the numbers on the other, cross multiply, and then solve from there. Now, as far as similar right triangles go, when we take a right triangle, so if I'm looking at this figure here, we're starting with this big right triangle that I'm highlighting in red. So I've got that triangle right there. And what's going to happen is we're going to take that triangle and we're going to put an altitude. So from that right angle, we're going to drop an altitude down here to the other side. So that's what this piece in purple is. Well, by doing that, we notice that I create a small triangle right over here. That's a right triangle. And I create another smaller triangle over here, which is also a right triangle. And so basically what we have are 3 different right triangles in the same picture. So we got the big overall red one, we've got the medium-sized green, and then we have the smallest triangle pink. And so what's going to happen here is within these triangles, all 3 are going to be similar to each other, which means the sides are all going to be proportional to one another. And that's why we kind of reviewed that geometric mean there at the beginning to kind of get us back into the mindset of proportions. So what's going to happen here is, given a triangle like we see here, when they drop that altitude, so here we have altitude B, D. Okay, so we've got this altitude dropping in, so now I've got three separate triangles like we highlighted on that last slide. What they want us to be able to do is write out the similarity statement. So triangle ABC is similar to triangle ADB, is similar to triangle BDC. Now, how did we come up with these three statements? So to do this, some of you might be able to look at the picture and just pick out which parts go together. But for most of you, it's going to be a little bit more complicated. And so what we're going to do here is we're going to create three similar right triangles. So off to the side, I'm going to draw one right triangle that's big. I'm going to draw another right triangle that's kind of medium sized. And then I'm going to draw a third right triangle that's smaller. So I've got a big, a medium, and a small. And so if I look at the big triangle, so I'm going to highlight that in green that I have right now. If I highlight that big triangle, I've got the points A, B, and C. And so in my picture, the right angle is B. So I'm going to label that B. A is that smaller angle, which I have up top. C is the bigger angle, which I have down below. But then we also have a medium-sized triangle. So the medium-sized triangle I'm going to highlight here in red. And so as I'm looking at that, I notice that my right angle now is D. My small angle is A still. And then my big angle would be B. So those are my three letters for that triangle. And then for my littlest triangle, which I'm going to highlight in kind of this purple color here. So for my little triangle, now I notice that my right angle is down here at D. I've got my small angle up top here, B. And then I've got my big angle, which is going to be C. And so now if I look at my statements here, so I went A, B, C for my first triangle. That's where I got this piece right here. Well, so I'm going to do that for the same, or I'm going to do that same thing for all three triangles. So A, D, B gets me my second triangle here. And then B, D, C gets me my third triangle. And so that's where this statement is coming from. So I'm going to separate my triangles into three triangles that are all oriented the same. Once I have them labeled, it's just a matter of putting them all in the same direction. Okay, so that's one type of question where we're going to have to write a similarity statement. So triangle ABC, similar to triangle ADB, similar to triangle BDC. And so that's just a matter of matching up corresponding parts. This is also going to be important for when we try to solve for missing pieces of the triangle. So on this next example here, here's the original problem. So off to the side here, I'm highlighting in purple the original problem. I've got this triangle. They threw this altitude in. And so what's happening is I'm creating my three similar right triangles. So the first thing I did, and this is what we're going to do with all these problems, is over here, I went ahead and drew a big right triangle. I drew a medium-sized right triangle. And I drew a little right triangle. So it's the first thing I'm going to do is just draw my three triangles out. Now I have to figure out how to label, and so you can start wherever you want on this, but if we look at the big triangle, let's say, so if I highlight the big triangle right here, so I'm going to highlight that in orange. When I look at this orange triangle that I've highlighted, I notice that this little or short side here is Y, and so that's why I put a Y on that short side of my triangle. The long side over here doesn't have any measurements, which means over here I'm just going to leave it completely blank. I don't know what that length is. But then if I look at my hypotenuse, so my hypotenuse over here, the longest side, I notice that I have an 8 and a 3, which together makes 11. That's where this is coming from right here. So I know these two parts, the Y and the 11, for that big triangle. If I highlight the medium-sized triangle, so I'm going to do that in green here. So for my medium-sized triangle, when I look at that now, I see that my short side or small side is X, so that's why I put the X there on the small side. I notice that my 8 is the longer side because there's my right angle, so 8 is going to be my longer side. And then if I look for my hypotenuse, that was that piece over here that we didn't have. And so we leave our hypotenuse completely blank there. As we go to the small triangle, so I'll highlight that in red. So if I look at my small triangle right here, I notice that my small side is 3, so that's why I put that as my small side here. The long side would be x, so that's why I put that there. And then my hypotenuse is y. So the first step is just going to be able to separate the 3 triangles and label them appropriately. Now at this point, because our figures are similar, that means all my corresponding parts are proportional. So all of my corresponding sides are going to be proportional to each other. So that's what these arrows represent. I can put x with 8 because those are both long sides of the triangle. And so I'm going to take x divided by 8 for one of my setups. Now, sticking with that same set of triangles, I can also match up the short side here, 3, with the short side here, x. And since I went x over 8, I need to go 3 over x. So this is that stuff we did back in chapter 7 where we set up and now we're going to solve the proportion. And so now if I cross multiply, x times x is x squared, 8 times 3 is 24, and now if I want x, I'm going to take the square root of both sides. X would equal the square root of 24. Now since that's not a perfect square, I look to break it down, and so 24 breaks down as 4 times 6. Since 4 is my perfect square, it gets to come out, and then the 6 stays put, and so there's my x value. When I go to look for y, so y here can match up with the 11 over here from the small triangle hypotenuse to the big triangle hypotenuse. I can match those up, so y over 11. And then if I'm going to go from small to big still, I can match the 3 up this time with the y, short leg with short leg. And so then it's going the same direction. I got 3 over y. And so now when I cross multiply, I get y squared equals 33. And now when I take the square root, y is equal to, the square root of 33 is not a perfect square. Nothing goes into 33 that's a perfect square, and so I just leave it as it is. So y is the square root of 33, and I'm done. So when we're working with these similar right triangles, the key is going to be setting up the 3 triangles, getting them labeled, and then matching up the appropriate parts. So here's another quick example. As we look at this triangle, here's my big triangle overall. And so after I draw my 3 triangles over here, my big triangle right here in blue has a short side of 6, so that's why we put the 6 there, a long side of x, so that's why we put x there, and then a hypotenuse of 12, which is why we put that there. And so we got all that stuff from the triangle that we had there. Okay. Now as far as my middle-sized triangle, so if I highlight that in red again, so here's my middle-sized triangle. I see that the short side is y, so I label my short side y. My long side in this case is 9, so I label my long side 9, and then my hypotenuse is x, and so that's where I labeled that x there. When I go to my small triangle, I'll highlight that in green. So in my small triangle here, now the short side, I don't actually have the number for, but notice how the whole length over here is 12, and this side was 9. That means that this side would have to be 3 so that I get that total of 12 every time. And so that's where this 3 is coming from on the short side. The long side then is y, so I put that on my long side. And the hypotenuse is 6, which is where I put that in there. Now from here, it's a matter of matching up corresponding parts again. So if I get rid of some of these markings here to make this a little simpler, we can kind of see how I started going about this. So as we're looking at my statements here, I've got this 3, short side, matching with this short side y. So I can put 3 over y as one of my fractions. And then since I went small to medium, I stick with that process. And so now I have y here matching up with 9 here, so long side to long side. So I put y over 9 to go the same direction. Cross multiply, I get y squared equals 27. When I take the square root, I get y equals, and now I have to break it down. 9 times 3 would give me a perfect square of 9, and so I get 3 square roots of 3. For x, we do kind of the same thing. So if I'm looking for x's, notice this x is a hypotenuse, which can match with this hypotenuse 12. So I can put x over 12 for 1. And then if I'm going middle to big, I need to stick with that process. And so now I can take the 9 here, long side, and match it with the long side here, x. So I put 9 over x. And when I cross multiply, I get x squared is equal to 108. When I multiply 9 times 12, when I take the square root, 108 is not a perfect square, so I break it down as 36 times 3. And so then the square root of 36 is 6, and the 3 stays inside, and so there's my final piece. So every time you're looking for those missing pieces there, you're going to set up those 3 triangles, label them with appropriate information, and then set up your proportions and solve. So with that, you should be able to work through the worksheet from class, and so you can get that off of Google Classroom if you weren't in class, and then ask questions if you have any questions on anything, or email, or check the answer key as it becomes available to you as you work to complete the assignment.